In this video, we're going to work through the practice questions that have to do with vectors and complex numbers. And let's take a look at our first question here. What is the result of adding the vectors a equal 3, 6 and b equals 2, negative 5? So we're talking about vectors here. We're adding the component. We're adding the x component of the vector, and we'll add the y components. So these are the x components, just like when you have x, y on a point. So to add these two up, and if you'll notice, you can also get a little clue from that in your answer choices. They look like they're in point form, just like the vectors are described here. So when we add them together, we're just going to take our x components, the 3 plus 2, we add those, and then we're going to add the 6 plus a negative 5. And we'll simplify here. 3 plus 2 is 5, and 6 plus a negative 5 gives us 1. It's the same as 6 minus 5. So we have the vector 5, 1 is the result, and that is answer choice D. Now let's look at number 2. It asks what is the magnitude, and that's given by this v in double bars, of vector v equals 4, 2. This is our format here. And again, from our review slides, we went over magnitude. And when we're looking at that, that is just the square root of the x component squared plus the vector's y component squared. So we can just plug that in straight here from our definition of the vector. We'll have 4 squared plus 2 squared, and that equals to 16 plus 4 under the radical, which is the square root of 20. And we can simplify that because, as a review for our radicals, that's the same as 4 times 5, and the square root of 4, we'll bring 2 out in front, and we leave 5 under the radical, and that is answer choice H, 2 on the square root of 5 for the magnitude. Now we'll go into some of the complex number questions. Number 3, what is the distance? This is a term we're familiar with. What is the distance between the point on the complex plane 4 plus I and the origin? Okay, so distance is the same distance we've always talked about when we've looked at the distance between 2 points on the xy axis. We'll remind ourselves that with complex numbers, it's given in the form a plus bi, where a is the real component, and the term on the I, that's the imaginary component. We have an understood 1 right here. So in our case, a is equal to 4, and b is equal to 1. And when we're talking about the origin, that is just 0 plus 0i, which is just 0, 0. Same origin as always. So when we're looking at the distance, we're looking at the square root of, it's almost like we do it with our points, 4 minus 0 squared plus 1 minus 0 squared. Now we'll work that on the inside here. We'll end up getting 4 squared, which is 16, plus 1 squared, which is 1, and that is equal to the square root of 17, which is answer choice C. Number 4 says, what is the midpoint of the complex points 3 plus 2i and 5 plus I? So we're looking for midpoint. Again, just like we could do distance with points, we can also do midpoint with complex points. And if we want to write this out in our form, since we have 2 points, let's say a sub 1 is 3 and b sub 1 is 2. Here a sub 2 is 5 and b sub 2 is 1. And since we're finding the midpoint, we're going to take the a values, the real values, add them up and divide by 2. That will give us the midpoint of our real component. So that's 8 divided by 2, which is 4. So this is the real component. Now what we could do here, because when we're working questions on the ACT, we want to work them correctly, but also as quickly as we can. When I first come and I find this real component, I can look through my answer choices and see which option has a real component of 4. That has a real component of 3, that's out, 2, there's 4, and then we have 8 and 8. So right now, without even completing working through the question, I know that the answer is answer choice H because it's the only one with the real component of 4. For the purposes of us learning, though, because that may not always be the case that we come to the one answer is the only one we have, let's continue on working to figure out the B component, which it should be 3 halves, but let's check. So we're going to add up each of the B components, divide by 2, and there we get 3 halves. This is the imaginary component here. And that follows along with answer choice H. Now let's take a look at question number 5. If the midpoint of two complex points is 2 plus 4i, and one of the complex points is -1 plus 3i, what is the other complex point? So in this case, we're given the midpoint and 1 point, and we have to find the second. So we're working similar to number 4, except we have some different unknowns. So in this case, we have the real component midpoint of 2, and that's equal to the real component of the first complex point. We don't know the second complex point over 2. This is how we find the midpoint. We'll multiply both sides by 2, and that's equal to -1 plus a2. So we have that real component of the one we're looking for equal to 5. And like we did before, I like to go through and look at my answer choices. Where do we have a real component of 5? That's -5, that's not going to work. -4, 1/2, and then D and E here both have real components of 5. So we do have to continue working through. We've got to find where is the imaginary component, either +5 or -5. So we're going to work the same way. Here is our imaginary component of the midpoint is equal to 4. That's equal to 3 plus B2 divided by 2. We'll multiply both sides by 2. We get 8 equals 3 plus B2. Subtract 3 from both sides, and B2 is equal to 5, that +5. So that makes answer choice D the correct choice there.